Welcome. In this lecture, I want to give an example that kind of puts together a lot of the new function terminology you've learned. So here we go. The example is going to be, so we can define a function. So this we haven't kind of done yet, so I'll show you. So we can define a function by saying, where each element of the domain goes. Okay, so let's show an example. So let's say we have this function L. So L is going to go from, it's going to start with the set 1, 2, 3. And then it's going to go to the set red, yellow, blue, black. So red, yellow, blue, black. Okay, and then I need to tell you where each element goes. So I could just tell you that L of, okay, so I'm going to tell you what L of each of these, there's 3 elements. I need to tell you where each one goes. So I'm going to tell you what L of 1 is, L of 2 is, and L of 3 is. So L of 1 is going to equal, it's going to equal blue. So let's say that this is going to equal blue. And L of 2 is going to equal yellow. And L of 3 is going to equal yellow. And this is totally okay that I have 2 things going to the same place, right? That just means that it's non-injective. It's still a function. The problem would be is if I said that L of 2 equals blue and L of 2 equals yellow. That would not be okay. Okay. So for in this example, and the colors should actually prompt this in your mind, then the domain is going to equal, so what we start with, 1, 2, 3, and the codomain is going to equal this this list that I gave there. Even though I didn't use all of them, it's still the codomain. Okay, and then so I suggestively made in orange this kind of image or range, right? It's everything that actually shows up as the output, right? So I'm going to get, you know, and this is a set, so it's blue and yellow. And this is good. It's a subset of the codomain like it's supposed to be. Okay. So here's a question. What if, now remember, and I know I'm duplicate using colors, so please don't get too confused by that. So if I want to take L inverse of X, so, sorry, we're going to practice with L inverse of X. So L, this is the pre-image, so pre-image. Okay, so let's do some practice with pre-images, so like pre-image L inverse of X. This is what we're going to do over here. Okay, and it may help, and so let's actually kind of, there's another way to kind of symbolically represent this, and this would be if I kind of wrote, so maybe I can write 1, 2, 3. Okay, and then this is going to get, and then I have here it is. So I have red, yellow, black, blue, black. This is kind of some, you know, there's a lot of different ways that you can represent things for yourself. And it's good to know them because sometimes, you know, a lot of times half of understanding a circumstance is representing it in a way that your brain can kind of sort out. So if I look at it this way, I'm going to say, so 1 goes to blue, 1's going to go to blue, 2 is going to go to yellow, so 2 goes to yellow, and then also 3 goes to yellow. Okay, and we notice that these two, you know, and maybe I'll even highlight this here, that these are my actual image. Okay, so now we're gonna play a little bit, and we're gonna try to find. So what happens if I take, I want to take, so this is like L inverse of the set that just includes the element black. Okay, so I need to look for everything that gets mapped to black. Nothing gets mapped to black, which means I get the empty set. Okay, so let's try another one. So let's do L inverse of the set yellow, the set just containing the element yellow. So looking at this, so if I have yellow, I can go back, and there are two things that go to yellow. I know that L of 2 equals yellow and L of 3 equals yellow. So this is both 2 and 3 are in the pre-image. So this equals the set 2, 3. Okay. And then let's try some more. So if I have L inverse of, and then I have red and yellow. Okay. So for red and yellow, I look at everything in the preimage of red. There's actually nothing in the preimage of red, but there are the same two things in the preimage of yellow, so I get 2 and 3. And then if I want to take L inverse of, let's do red, blue, black. Right? What am I going to get? So I'm looking at red and blue. So nothing in the preimage of red. In blue, I get 1. So let's list that before we forget. And then there's nothing in the preimage of black, so I'm done. Okay, and now let's try one more, which will be L inverse of red, yellow, and blue. Okay, so for red, there's nothing. For yellow, I get 2 and 3. And then for blue, I get 1. Okay, and then we can make some observations. So one observation is observe that all of these pre-images, right, are subsets of the domain. So observe so each L inverse of X, right, is a, is a subset of the domain. Right? And another thing is that it's okay that, so if we look at this, right, for yellow, I actually have 2 things in the preimage, and that's totally okay. Okay, so it's okay for a single element set, such as, right, we had an exact example of this, such as when I had the set yellow, the set containing just the element yellow, right? It's okay for a single element set such as the set yellow to have multiple elements in the preimage. Okay, great. So, right, this also, so we kind of went through multiple things here. One was just that there can be more than one way to write a function, and sometimes you, like, if you're having trouble sorting something out with it written out in one way, sometimes it can help to switch over and write it out in another. And so, we could have a function like this. It's okay that 2 things went to the same place. And actually, let me add in a little bit of, we're going to add in some extra notation here, just so that familiarize you with a little bit more notation all at once. So we could write this as, so 1, 2, 3. So remember that we had this notation where we could say, so 1 goes to blue, or 1 gets mapped to blue, right? We can have that 2 gets mapped to yellow. 3 gets mapped to yellow, so that's just other notation for exactly the same thing. Oops, close my parentheses. Okay, and right, so our domain was all my inputs. My codomain was all the possibilities for outputs. It's usually like listed there, but you might not hit everything, and what you do actually hit, what actually does show up here, or like as arrows pointing to it, is called the image or the range. And so this is just another way to kind of write this. And then when we're doing the pre-images, we have to remember this is not an inverse function. We don't even know that an inverse function exists. In fact, in this circumstance, it doesn't, because this function is not injective or surjective. But you just list everything that goes to the element. Right? And so it's okay when there's like 2 things in the preimage of a single element. That's okay. There were 2 things that went to that kind of went into that set. It was just yellow. And then the other thing is that notice that all of these things, so you take preimages of things in the image, or in the codomain, you take preimages of things in the codomain, and then you take, and their outputs should be a subset of the domain. Okay? And maybe actually one more observation here was that, you can have, like, it's okay that, like, for example here, it's okay that this just, like, isn't, so it's okay that nothing goes to this. You just then kind of ignore it. Okay, so I hope that made some sense and was helpful, and I will see you in the next lecture. Sure.